Today I'm going to talk about tail calls in JavaScript and a little bit about tail calls in general. First of all, let me describe briefly what a tail call is and why do we even care about them. So tail call is a function call which is the final action of another function. So let's take a look at this example. We have function A, which calls function B, and it just returns the result of invocation of function B. So it's really the final action of function A. So we say that function B is in tail call position here. Let's take a look at another example, which is a little bit more complicated, because here, even though that if you look at the code, B is really the last invocation of B is really like the last expression that we can easily see. But in reality, the last operation in the function is addition of 1 to the result of invocation of function B. So B here is not in tail call position. It's important to see these differences because sometimes we need to change the way we write our functions to ensure that we have a tail call there. And I think that the most important example is a recursive tail call. Here we have recursive function A, which calls itself with possibly different parameters to avoid infinite loops. But yeah, that's why like the most important example here, because we see in a second that recursive tail calls are pretty neat. So now, what about tail call optimization? If you have tail calls, like we can optimize our code during execution, so it's more performant. So let's take a look at this code. This square represents, this green square represents the stack frame. So in the beginning of the execution of the program, let's say we're here at point C, we're in global scope, we're starting executing function f, and to do this, we create so-called, execution engine creates so-called stack frame. Stack frame is a place in memory where we put all arguments of the function, all local variables, and a return address of the function. So basically, these are all the information that are needed during runtime. And each function call produces another stack frame. So let's see, we're modifying some variables in function f, and now we're calling another function, id, in point B, and that results in creation of another stack frame, and for id function. And after last function, id function finishes its execution, the stack frames are deleted, and the program execution goes back to previous functions. So it works like this. Then we're in function f, and then we're again in global scope. So if we notice that actually in function B, we have a tail call. We're tail calling function ID. Actually, we can realize that we don't need to produce another stack frame. We can just take the one that we already have and just reuse it. Push different parameters and don't change return address at all because we want to go back to previous function. Yeah, and that's basically idea behind the tail call optimization. So we're using stack frames so our program is more performant. Yeah. And why is that important? You saw on the example that we can reduce amount of stack frames by 1. So it's not that impressive, but the real reason are recursive tail calls, which are in functional programming languages, recursive functions are much more used than loops, for example, because they can you can express the same ideas in a better readable way. So that's why recursive functions are favored there. And yeah, so does JavaScript support TCO? JavaScript is, of course, functional language, so it should, right? But the problem is that it doesn't. And I mean, with ECMAScript 6, one of the requirements for JavaScript engines is actually to support TCO. But as for now, only WebKit does it. So it's really pain in the ass to work with TCO in JavaScript, because all the major browsers like Chrome, Edge, I don't know, Firefox doesn't support TCO. And the problems that we can have are, for example, this. We have function counter, which just counts numbers up to a given number. And for given big parameters, we can exceed stack size, call stack. So it results in a runtime error, and we don't get answer that we hope to get. And another example is, for example, recursive Fibonacci function, which is, in my opinion, quite readable, but actually in JavaScript it's not too useful, because for big enough integers it stops working. We can work around these limitations. One of the ideas is to use a concept of trampolines. Again, it's like general concept, not only in JavaScript. So actually, instead of calling a function when we're supposed to call it, we can return anonymous function. Here, I create an anonymous function by using bind. In JavaScript, I could also create really here anonymous function and just return it. And it hides the execution of itself. So to use it, we need another wrapper for this function, which invokes this function until it returns something different than function. So by using trampolines, we can make sure that we grow our call stack only by 1, which is very good, because now we can work with big inputs. The only problem here is that creating anonymous function is not for free. It costs us, and it's a performance hit that we're getting here. Yeah, that's the execution of the trampoline with Fibonacci. And another idea is to rewrite our code to use while function, while loop. It's actually pretty easy after you do it for a few times. So we can, instead of having this readable form, we can rewrite it to while loop. The code is more imperative, so it's also easier to make some mistakes, but it works, and it works fast. Yeah, the only problem here is that we're sacrificing code readability quality for performance, and most of the times we shouldn't do this. We have different tools like compilers, transpilers to do it for us, and that's where we're heading. We're heading to automatic solutions to these problems. So, as always, there's a Babel plugin for that. Babel plugin telco optimization which it happens I'm just the author, just does exactly what the previous example shown. So it searches for recursive functions with tail calls, and then proceeds to rewrite it to use while loops. It's kind of tricky. There are a lot of edge cases to do it right. For example, if inside of recursive function that we're going to change is a closure, there's a closure, it won't work after we rewrite a function, because in while because of functional scoping in JavaScript. Basically, after using while loop, you would all the closures would point to the exact same variables, which is not what we want. Most of the times, it's not the same behavior that in the previous example. So, for example, Babel this plugin detects this and just keeps optimization there. So, what are the benchmarks? It turns out that it's almost 5 times more performant after TCO optimization with plugin. So it's quite huge gain for free for just adding one dependency to our project. Yeah, what about mutual recursion? Nope, it doesn't support it. I think it's not a huge problem, because even Scala functional language running on JVM doesn't do this. So I guess it's not a huge problem. Here's a link to plugin. So to sum up, tail calls are a pretty important feature in functional languages. We can use functions, recursive functions, to iterate over lists, to count length of the list, and many other more useful things. And without TCO, all this example would fail for bigger input. And yeah, that's actually the point of having TCO. And even imperative languages like C, GCC does TCO for pure C. So I guess it's quite common, and it's a shame that JavaScript in 2016 doesn't support it natively. I mean, most of the engines. Yeah, and that's all, folks. Thanks for listening.